Okay, histograms. We're asked to estimate the mean height here and draw a histogram to represent this data. So it's going to be the mid interval value times 9 and so on. So 9 by 142.5 plus 65 by 147.5 plus 177 by 152.5. It's kind of slow and meticulous. Plus we're here 157.5, 325 by 157.5 plus, and you have to double check all your answers when you use a calculator, so a bit of work involved in this one. So we've got 253 by 162.5. We have 133 by 167.5. We have 31 by 172.5. And finally we have 7 by 177.5. And if you multiply all of these out, what are you going to get? Let's have a look. 159030. And we're told that there were 1,000 women, so divided by 1,000 is going to give 159.03 cm as the best estimation of the mean. And then we're asked to construct a histogram. Well, I'll just do a sketch of a histogram just where I can see the data. So you guys are going to use a ruler and come up with your best scale. We have cm and we have frequency. So if we start with the first one, just say, we can see they go quite high, from quite low to quite high, 325, 253. So we've kind of got like a 300, a 200, a 100, all around 100, 200, 300 there in the middle 4. So we have a small guy, that's a 9, maybe a bit too wide. Small guy, that's a 9. Then we're coming up to 65, so about 7 of them. So this is just a sketch. Then we're coming up to 177. We're coming up to 325. So you can see this looks like a normal distribution. Most of the data being concentrated in the middle, or 68% of it, within one standard deviation of the average. So we've got our 9 or 65 or 177 or 325. Now we've got our 253. We've got our 133. So just slightly below this 177 here. So 133. Just come out a little bit. And we've got our 31. And our 7 just slightly below our 9. So really I'm just drawing this to show you the shape of this distribution. It's not easy to do exact. So the shape of this distribution is normal or symmetric, or some other term you might have used within normal distribution curves. If we go on to question 10, the following data are daily max temperatures in Dubai. So again, look, we've got how much information have we got here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30 pieces of data here that we have to tally. Okay, let's start with row 1. 29.2, 36.2, and 31.1. Okay, we go to the next row. 29.4, 32.3, and 33.9. So we've got the first 2 rows done. So we just mark them off. Done, done. 34.1. You're better off taking your time with these, or you get to the end, you add them up and they're 1 away from the total. So take your time. 34.1. We may not have enough room here either. I don't think they have given us enough room. So we just create a couple of boxes down the bottom. So 34.1, 32.6, and 34.7. So that's the third row done. On to the fourth row here. 36.3, 36.5 and 34.3. So that's that one done. So the first four done. We're on to the fifth one, 36.5, 33.8. That's going to give me 5 there, 33.8, 37.3. So we've got that row done. So now 32.1 in here. And another 32.1 is going to give me 5 there. And then 40.9 is up here. That's that row done. That column done. Now we have a 32, 32, 31, 32, 33, so another 1 here. 32.2 is another 1 there. And 33.8 is another 1, 33. So that's those 3 done. You can see it's pretty time consuming, so the stats questions might not have a huge amount of maths in them, but can probably be more time consuming than anything else. Okay, 35.7. That's the fifth one there. 38.8 and 32.2. That's that one done. 35.6, 35.6, 36.5 and 40.9. That's that one done. And then 34.9, 35.7 and 34.2. Looks like we have, let's see, we have a 2, we have an 8, an 8, an 8, a 2, a 2. What are we asked to do? Describe the distribution. Well, with the 2 on here, there's a tiny skew to the right here. It's perfectly symmetrical. It goes 2, 8, 8, 8, 2, and there's a tiny little 2 off. So we could say it's kind of skewed right maybe here. Skewed a little bit right, just a tiny bit by this extra 2 on. So that's the histogram, the shape. Rank the raw data and find the median. So we have to rank and find the median. Now ranking the raw data is ranking them from 1 to 30. So when we have the median of 30, we want the 15th and the 16th. That's what we want. So let's cheat a little bit. The first 10 pieces of data are in here, and then up to 18 is going to be in here. So we just pick out the 33, the 35s. Let's underline them. 33 and 34s. 33 and 34s. There's 1, 2, 3, 4, 5, 6, 33 and 34, 7, 8. Okay, there's my 33 and 34s underlined. So if I imagine they're the 11th, the 12th, the 13th, the 14th, the 15th and the 16th, it's the 5th and 6th one of these that we want, the 5th and 6th. So can we got the lowest ones? 34s, are they all 33s? How many 33s? We can eliminate the 33s. 1, 2, 3. That's the 33s eliminated. So that's 1, 2, 3. So now we have the 14th. What's the next one? The lowest 34. Has to be 34.1. And then we have a 34.7, 34.3. A 34.9 and a 34.2. So the 34.2 will be next, followed by the 34.3. Giving a median of the interval, mid-interval value between these two is 34.25. And then we're asked using mid-interval values, estimate the mean of the distribution. Okay, I'll just give myself some room over here. So mid-interval values with 29, 30 by 2 plus 32 by 8 plus 34 by 8 plus 36 by 8 plus 38 by 2 and plus 40 by 2. And multiplying all of these out, we are going to get 1032 divided by, do we add them up at the beginning? We didn't add them up, we weren't told. There's 30, we did, we had 30 of them. Give me 10 rows of 3, and 1032 divided by 30 is 34.4 degrees Celsius. What did we get? Have we done this before? No. So that's the mean. Now using the raw data, calculate the mean. So we gotta add all these 30 together, I'm afraid. For this one, you can see 2 questions look quite short, actually quite time consuming. So adding all of these together, the sum of all these values, one number after another number into your calculator. Don't be tempted to try and take shortcuts. Yeah, 1035.8 is what it's giving me. And if I divide that by 30, we had 34 up here for the mid-interval values. 1035.8 is going to give me 34.526, repeated a couple of times, 34.52, I'm going to go 53 here, degrees Celsius. And we are asked what's the percentage error. Well, the percentage error is in the estimated mean, which is this guy here. So what's he out by? He's out by 0.13, and it should have been 34.53 times 100. So again, quite a small number, 0.03648. So 376 we go percent. So less than 1%, just over a third of 1%. So frequency distributions. Practice a few more of these.